Hello everyone, my name is Guo Chen. The title of our paper is Learning a Practical SDR-to-HDRTV Up-conversion using new dataset and degradation models. So our task belongs to low-level vision, and our task stems from the discrepancy between the HD and UHD system in media industry. This discrepancy lies in five aspects, and the first three belongs to resolution, which is solved the other low-level vision tasks, and the rest two belongs to expressiveness, which is our concern, and that is our task convert SDR CCG content to HDR WCG content using an inverse tool mapping operator. So um, these are our concerns and our consequent responses. So for the training data of learning-based methods, we propose a new HDRTV 4K dataset. And for the model design, we designed a new luminance segmented network. And for the assessment criteria, we use some HDR-WCG tiled matrix and subjective experiment. So the first part is our new HDRTV 4K dataset. Our motivation lies in that the VDU workshop in both this year and the last year CVPR says the dataset is the fuel of CV, but its impact has long been underestimated. So it's the same in our field, and we have distilled the two ingredients of the training process. The first one is how the target GD should be, and the second one is what degradation the network can learn. So based on this, we have distilled four specific concerns, respectively, on the label HDR and input SDR of training set. So first, we improve the diversity of label HDR by collecting several individual frames from more categories. And these frames, when we map them to a latent space, as we can see, the label HDR in our HDR-TV 4K dataset is obviously more diversified than others. And also for the label HDR, its quality is also manifested in the how many advanced HDR WCG volume it has. So we propose four metrics to measure them respectively from the spatial fraction and the numeric extent. So that is how many advanced, luminance and color volume the HDR label has. And we use this matrix to compare different label HDR in different datasets. And as we can see, our label HDR contains more advanced luminance and color volume, so the network will have more chance to produce them. And also, we need degradation models to degrade the label HDR to input SDR during training. So we use three different degradation models. The core idea of our degradation model is hard clipping on both the luminance and color. So it produces more clipping, and consequently the network will learn more recovery. Also, the degradation models will not excessively enhance the style during the process from HDR to SDR. So the network will not learn a vice versa SDR to HDR style deterioration. So that's the four aspect a better training set would benefit the network. Also, after obtaining the training set with better quality, we use a new network to do the process of from SDR to HDR. Our problem formulation is that we think different degradation occurs in different luminance range of input SDR. So respectively in bright and mid and dark area, they have different type and extent of degradation. So consequently, the network should have different recovery capability. So we use a multi-layer perceptron with modulation, that is the left part on the midtone, and two transformer unit respectively on the bright and dark area. So our network design is that we first segment the luminance of SDR to bright and middle and dark, and respectively process them with network with different recoverability. So the network on bright and dark is stronger. Another thing is that how the luminance should be segmented. The first, we treat the whole SDR as midtone for MLP to process and let the transformer to predict the residual that is something beyond the MLP's capability. And we map the SDR's bright and dark range to a more significant value, that is 0 to 1, which is easier for a neural network to process. And that's how the luminance is segmented. Okay, and the last part is experiment and this criteria. So we have trained our network using the new dataset we proposed. So this is experiment. Our task is different from others in that it has several new assessment criteria. So we use subject experiments and timed metrics to assess if the result is good from brightness, saturation, information recovery artifact, and the expansion of the advanced color and luminance value. First, from the XY chromaticity diagram, we know that our method expand more advanced color and luminance value, meanwhile recover better dark and bright area. And we did some subject experiment that SDR and HDR are shown side by side, and participants are asked to score and select attribution. And also we have some timed metrics that our method is able to recover more advanced volume. So that's a result. And please refer to the paper for more demonstration and explanation. Thank you.